Good afternoon, children. Shillong, Itanagar, Chuachandpur. How are you? Tamenlong. Good afternoon, everybody. How are you? Good? Yes. How are you, children? Back from the break. Long lunch break. You people are nowadays taking very long lunch break. I came to know that. Okay, fine. Okay, how is your... So what did you have today in lunch? You did not come back after lunch? Centers, mushroom? Wow, nice, very good. Good, nice. High protein diet, very good, Shillong. Okay. So let's start protein with that note, isn't it? With high protein diet, let's start protein. So what were we doing yesterday? Who is going to remind me what was the topic? And before that we move ahead, just let me know if we have any doubts from the biomolecule section. The whole things that we did yesterday with the amino acids. Any problem with amino acids? Anybody? Small, big, confusions, problems? No, no problems? Are you sure? Everybody? Are you sure? So what is a zwitterion? What is a zwitterion? Who is going to answer me? Let's see. First, from all the 4 branches, centers. Shillong, Tamenlong, Itanagar. Yes, Senapati, good afternoon. How are you? Let's see who is going to answer first. I won't be able to see you today. But yes, don't start sleeping in the class, post lunch effects. Okay, don't sleep in the class. I will be asking random questions. Yes, very good, very nice. Yes, Senapati, what is a zwitterion? What do you understand by zwitterion? Yes, very good, Shillong. Nice. Okay. Yes, very good, Tamenlong. Nice. Keep it up. And who else is logged in apart from Shillong, Tamenlong, Senapati? Who else is logged in? We'll be getting back to you soon for that, Shillong. Okay. Yes, good afternoon. We'll get back with those things, test and all those things soon. We'll back with that particular thing. But you obviously keep on studying all those chapters without any delay. Okay, so let's start with proteins. Since Shillong had mushroom in lunch, so we'll start up with proteins. Okay. So we were doing what? We were supposedly doing biomolecules, isn't it? So let us continue our class. And today we will start with proteins. So this particular word protein is basically derived from a Greek word. Okay. So in Greek this word actually means holding first place. Now you must be understanding the importance of protein with this thing. So in Greek this term protein means holding first place. This was basically, the name was termed by Berzelius and Mulder. So what is protein composed of? Now since we have done amino acids, we are very aware of all those things, and we know that proteins are composed of carbon, hydrogen, oxygen obviously essentially, and apart from that we have nitrogen also. Now some of the proteins, they also contain some different kinds of molecules, like they might contain iodine, they might contain iron, or they might contain phosphorus additionally. So apart from the compulsory things, that is CHON happens to be the compulsory elements present in protein. Now apart from this, we can also have iodine, iron and phosphorus in the molecule of protein. So by now we have gone across the structure of amino acids, and we now know that there are 20 different amino acids going to constitute different types of proteins. So all the proteins, they are basically what? They are basically heteropolymers. We would call them heteropolymers of amino acids. They are heteropolymers of amino acids. So all the amino acids, what they do is that they polymerize together. Obviously we have done yesterday, we did yesterday's class, we learned a lot of amino acids. Okay, with that note, who is going to tell me the amino acid with OH group? Name the amino acid containing OH group. Amino acids or acid. Yes, good, very good. Let's take on this spelling also. Okay, the amino acids with OH groups are 2. It is serine, it is threonine. Very good. Okay, so these are 2 amino acids with OH group. So proteins are basically what? They are basically the, so can I give you a statement, like if I am like I did not tell you this thing yesterday, can I give you this statement that amino acids are substituted can I tell you this thing, that amino acids are substituted methanes? Can I? Yes, I can. So we have to keep this thing in mind, that amino acids are what? Amino acids are substituted methane. Okay, so we did yesterday's class, we did amino acids with particular nature, that is with neutral, basic, acidic, everything we did yesterday. We saw the formation of peptide bonds also. I told you that peptide bond is what? Peptide bond is actually a kind of covalent bond which is exclusively present between the amino acids. And I told you what is a dipeptide. Dipeptide is what? Dipeptide was a molecule present between the two molecules of amino acids. Now going further, let's see quickly the structure of protein. So what is the structure of protein like going to be? We will divide it into 4 basic categories. Structure of proteins, we'll divide into 4 basic categories. Okay, that first one is going to be the primary structure. Obviously, as the name suggests, this is the basic structure, and just like any basic structure, this structure is basically what? Going to tell you the sequence of amino acids in a polypeptide chain. So it's what? It's sequence of amino acids where sequence of amino acids in the polypeptide chain. So what you have to do is that you have to design a polypeptide chain, and in that polypeptide chain you have to tell us the sequence of amino acids. For example, I will just give you one small chain: lysine, leucine, tryptophan, sorry, this is tyrosine, this is tryptophan, isoleucine, valine, glycine, threonine, serine, like this. So there can be amino acids which can be repetitive also. Let's like add one more over here. So this is what, this is a basic sequence where I can say that yes, the first amino acid happens to be isoleucine, second happens to be lysine, third this, and up to there, obviously up to n number of amino acids we can add in the chain. I told you all those things yesterday also. So we have a whole sequence of many amino acids linked together by what bond? Linked together by peptide bond. So this is important, you need to learn that yes, peptide bond is present between the basic amino acid bonding. So this is what is the primary structure of protein going to tell you. So what it is going to tell you? It is going to tell you the sequence of amino acids. Like if a question comes to you in the following polypeptide, which is the fourth amino acid, obviously you are going to refer to what? You are going to refer to your primary structure of protein. Now moving ahead, if you talk about the secondary structure of protein, let's talk about the secondary structure. So if you see the secondary structure of protein, secondary structure of protein is modified from the primary structure. How? If I take this polypeptide chain, just I pick up the polypeptide chain and start to make different kinds of bonds among them. For example, if I start to make this kind of bond, start to make, rotate it in a helical form, this would be my alpha helix. Obviously for alpha helix I need one polypeptide chain only. Now if I am like taking two polypeptide chains and I am just making bonds in between them like this, this kind of bond, this is what is called as beta pleated sheet. So this obviously takes place when we have two polypeptides. So if you have two polypeptides, you would end up in making what? You would be ending up in making beta pleated sheet. So this is the basic structure of protein, where we talk about the alpha helix, we talk about the beta pleated sheet. This is what is the secondary structure of protein. Yes, Shillong, this is you, this is you. Bio class droppers, just wave me your hands, wave at me please, just to cross check, or if everything is clear, just give me a thumbs up. Okay, finally, nice, nice to see you all. Okay, so everything is clear till now? Am I clear up to this, children? Just let me know if I am clear up to this. Everybody, Tamilong, Senapati, Shillong, there is one more center logged in. Okay, Itanagar is very quiet today. What happened, Itanagar? Not in mood to study? हाँ, मम्मी ने ज़बरदस्ती भेजा पढ़ने को. Itanagar, why not responding? Are you there, children? Okay, so let's move ahead. So just for example's sake, we will like just have an idea that in nature there is no left-handed alpha helix for proteins. Okay, there is no left-handed alpha helix for proteins. There is only and only right-handed alpha helix. Okay. So this starts and this starts to move on your right side. So yes, Tamilong, Just pay attention. What primary structure of protein tells us about is the sequence of amino acids. That's just about it. If you go across the primary structure of protein, you will find that, okay, this is my first amino acid, second amino acid, third, fourth. So if you put all the amino acids in a sequence, and if I ask you a question that, yes, what is the fifth amino acid? You will be saying, for example, over here, I have tryptophan. So you will be telling me it's tryptophan. So this is what is the primary structure of protein going to tell you. It is just the sequence of amino acids in an order. That is all about the primary structure of protein. Arrangement of amino acids in a polypeptide chain. Polypeptide means many peptide bonds are present. Okay, clear? Yes, Itanagar, clear? Tamil Nadu, clear with the idea? Now, if you talk about the alpha helix forms, the most important examples that are counted are keratin. Where do you have keratin? Quickly tell me, where do you have keratin? Did I teach you myosin? Did I teach you myosin? Yes, children, tell me. And did I teach you tropomyosin? Did I teach you all this? So this is the alpha helical form of protein. Alpha helical form of protein, they are basically present in this form. If you talk about beta pleated sheet, we have beta pleated sheet as fibroin present in silk. So your silk has what? Your silk has beta pleated sheet. Clear? Yes. So keratin, you must be aware about bonding and rebonding, all those things. Many people are going into those particular things. Any idea about bonding and rebonding? Yes, it is present in the most important protein of your skin and hair, exactly. And hair rebonding things are very common these days. Do you have an idea? What is rebonding about? No idea. Actually, don't need rebonding, I guess. Okay. So what happens is basically what keratin is having. Let's have just kind of thing out of box. This is not going to be as neat, just out of box thing. Keratin is rich in amino acid cysteine. Cysteine. What was cysteine? I taught you yesterday, this was a sulfur containing amino acid, remember? So, if it is a sulfur containing amino acid, what kind of bond it would be richly making? It would be making disulfide bonds. So, basically what happens is in the hair, we have certain disulfide bonds, and when we wash off your hair with shampoo or soap, any kind of thing which obviously breaks up these disulfide bonds, what happens is the hair tangles, they are straightened. What bonding is done, bonding and rebonding, all those things, what they do is that they use permanent chemicals that are used to break those disulfide bonds. So if it's long since you washed your hair, what happens is the single hair the hair structures, they start to form bonding among themselves, and because of this particular structure, what happens is the hair starts to show, like whatever you can say, dust particle, oil, all those things. When we shampoo our hair, what we do is that we break those disulfide bonds present in the hair and among the hair, and this is basically the reason behind why we feel so good after a head wash. Okay, so now you can go back home and tell people that why it is good to do head wash. Okay, so how does the rebonding things also are working. Now we are done with the structure of the protein, the particular structures. We are done with primary structure, we are done with secondary structure. Let's quickly come to the tertiary structure, obviously third degree, tertiary structure of protein. So we are moving our level up. So what is tertiary structure of protein about? tertiary structure of protein tells you a case where what you do is that you are just folding the secondary structure again. You will take the either of the alpha helix or beta sheet and you start to fold them. Folding of, I will write 2 degree as secondary structure to give a globular appearance. Globular means what? Just a rounded kind of structure you are going to give it. So, these particular structures, a tertiary structure, they have a characteristic property that what? That they are soluble in water. Okay. So, I mean to say what? They are colloidal in nature. Okay. I have taught you what is colloidal. But yes, there is a limitation for this thing. What is the limitation? They need certain bondings. We have hydrogen bond, disulfide bond, we have hydrophobic bond. You must be aware about all these bonds. We have ionic bond. So, these are the basic 5 different kinds of bonds that are basically responsible for making tertiary structure of protein stable somewhat like this. So, it is very surprising that majority of the biomolecules, whatever you have functional in your body, let us take example of enzymes, example of any of the biomolecules, maximum of the biomolecules present in your body, they are having the tertiary structure of protein. So, tertiary structure of protein is the most abundant structure present in your system, present in our body, that is tertiary structure of protein. Clear with this, everybody? Shillong, Tamenlong, Senapati, Itanagar. Yes, children. Tell me, shall I move ahead? Shall I move ahead? Shillong? No, you're copying. Okay. Please copy. Are you able to see the whole slide? Yes, everybody. Are you able to see the whole slide? Copying? Please copy. Anything left to copy? Okay, there was a confusion yesterday. Yes, I am scrolling. Yes, please. This page, Senapati. Okay, there was a confusion yesterday. I told you about chiral carbon, that it is a particular carbon to which 2 functional groups are attached. I just confirmed with Sube sir. We need to have 4 different functional groups attached to the same carbon, and then only we can call it to be a chiral carbon. Okay, to just rectify your notes, we did yesterday where we talked about chiral carbon as the particular carbon having 2 functional groups. Just rectify it with 4 functional groups. So, all the 4 should be different. That was the thing told to me by sir, that all the 4 needs to be different. Okay, just rectify this please, children. Yes. Okay, fine. Yes, Senapati, Tamenlong, Shillong, things are clear up to this? Shall I move ahead with the next level of protein? Yes, no? Yes, children? Done? Copied? Tell me something, I will move ahead. Okay, fine. I guess we all have copied, and will proceed with the quaternary structure of protein. Number 4. So what is quaternary structure of protein doing? Quaternary structure of protein is basically talking about the interactions between two or more tertiary structure. So if you are taking two or more tertiary structure, thus making a bond between them, that would be called as the quaternary structure of protein. Let's take an example. This is 1, this is 2, this is 3, this is 4. So we have taken 4 tertiary structures. Obviously the black ones represent the same kind of tertiary structure, and the green one represents the similar kind of. This kind of structure of protein is said to be what? Is said to be quaternary structure. Let's see. We have all studied the beta chain, alpha chain, alpha chain. What is this? What is this? What is this? Quickly. What is the structure? Why it is taking so long? This is hemoglobin. So hemoglobin is one of the examples of what? One of the examples of quaternary structure of protein. This is serious. You're not able to identify hemoglobin structure. This is serious. What is the preparation? What is the preparation going on, children? Not able to identify alpha to beta 2 chain of hemoglobin, and you are done with human physiology. What is going on? This is sad, very sad. Yes, Shillong, what is going on at back bench? 4 of you, what are people doing? Yes, this section with higher density of children. Yes, last, what is going on? What is the gossip about? Shillong Center, calm down, please calm down. Okay, fine, copy it. So this is the quaternary structure of protein. So we are done with the primary structure, secondary structure, tertiary structure, and quaternary structure of proteins. Do we have any doubts up till now, or shall I proceed with lipids now? Do we have any doubts, children? Do we have any doubts? No doubts? No doubts? Tell me quickly. No doubts? Tamilong, Senapati, Itanagar, what about you children? No doubts? Shall I move ahead with lipids? Okay, very good. So what is the particular kind of protein, amino acid present in your system, L form or D form? What's the L form or D form of protein? What is it? D amino acid or L amino acid? What do you have in your body? You know what is L form and D form, isn't it? Dextrorotatory and levorotatory. Obviously, you can consult more about it from Sube sir. But apart from that, what is the amino acid form you are having in your body? Now let's see. The biological forms, they have L amino acids. Whereas D amino acids, they are present in the peptidoglycan cell wall of bacteria. So we have two different types of amino acids. We have L amino acid and we have D amino acid. L form present in the proteins and D form present in the peptidoglycan. Vineet sir must have taught you the cell wall structure of bacteria by now. So it's present in the cell wall of bacteria. Clear? I'm moving ahead with lipids. So what are lipids? Obviously fats plus its derivatives. Fats and its derivatives are said to be what? Are said to be lipids. When you take into account the fat molecules along with the lipid molecules and fat and its derivatives together, we call them to be lipids. So what we have more about it is that they are compounds, no doubt, as we did yesterday. They are compounds of carbon, hydrogen, oxygen, but here ratio of H is to O is not 2:1, because till now what we have studied everywhere the ratio happens to be 2:1 in a particular case. This is basically not 2:1, and we have to make a special note that oxygen has a very less amount. So there is very less amount of oxygen present in whole of the structure when you talk about. So this is what we say. About the molecule lipids. Clear up to this? Everybody? The next important characteristic property of lipids happens to be what? They are water insoluble. But soluble in organic solvents. Obviously, you know what are organic solvents? Chloroform, benzene, alcohol, ether, all of these. So lipids are seen in protoplasm also. in form of small globules. So these are the particular characteristics of lipids. Continuing ahead. So lipids are known to provide you more energy. Compared to carbohydrates. Yes. Things are clear up to this? These are properties of lipids. The most important property of lipid which is not present in any of the other molecule is that lipids do not form polymers. This is the most important characteristic property of lipids which is not present in any of the other biomolecule. All the other biomolecule, if you remember, yesterday we made a monomer and then we subsequently made a polymer. But for lipid, these kind of things are not existent. So lipids, they are not at all having this particular property that they can act as monomers or polymers. So they don't have polymeric form. So as amino acid used to have polymer of what? Polymer of proteins. Similarly, nucleic acid was a polymer of nucleotides. Monosaccharides, they polymerize to form the carbohydrates, but lipids don't form any kind of polymer. But we also know at the same time that they are what? They are micromolecules, isn't it? Why micromolecules? As their molecular weight does not exceeds how much? How much is the molecular weight? It does not exceeds 800 Dalton. So because of this property, what we have is, we have the lipids to be the class of sort of micromolecules. We did this yesterday. So which will take a more space to accommodate. Copied up to this, children? Which will take more space to accommodate itself. Copied, everybody? All the centers, Shillong, Tamenlong, Senapati, Itanagar, everybody copied. I am moving ahead. Okay, next thing. What we have is, we'll just refer to the properties. Require less space for their storage. Why? Why? Because they are, compared to carbohydrates, as they are hydrophobic in nature. So being hydrophobic in nature is an added advantage for them. For what purpose? That they are requiring less, comparatively very less space for their storage. So they need a very less space for their storage compared to carbohydrate because of their hydrophobic nature. Okay, fine. Clear with this idea, whole things. So we also have two kinds of lipids. Your lipids which are called as, some of them are called as fats, some of them are called as oils. Obviously this differentiation is on the basis of melting point. The oils are known to have less melting point, I will just write MP, and this is known to have a higher melting point. So the difference in melting point is one of the most important characteristic property that fats and oils have. So oils, they have less melting point. You must have seen the oils, they are liquid in nature already. And if you talk about fat like butter, ghee, isn't it? They have to be like put in the vessel, and they need to be heated a lot to just melt them. So they are having what? They are having basic nature is having high melting point, whereas in case of oils they are having a low melting point. So this is the basic criteria on the basis of which we have differentiated fats and oils. Further, there are certain lipids called as phospholipids, which are forming lecithin, which is a component of cell membrane. Now let us move to the different types of lipids on the basis of their reaction and all those characteristic properties. So this is important, phospholipids. So when sir will teach you cell membrane, he would tell you about phospholipid. You can just tell them that yes, phospholipid example is lecithin at that time. Okay. So sir will be teaching you phospholipids when he will be telling you about cell membranes. Clear everybody? Is it clear to one and all? Yes, Shillong? Clear? Clear, children? Copied everything? Sure, not missing out on any point? Yes. Okay, let's see the types of lipids then. Can we start with types of lipids? Tamilong, Senapati, Itanagar, Shillong, clear everybody? I am starting with types of lipids now. So, we will divide lipids into three categories. The first will be the simple lipid. The second is going to be the compound lipid, and third is said to be the derived lipids. Let's start with first. It is simple lipids. So we did digestion section, there we saw the breakdown of lipid. If you remember, glycerol, triglyceride was the they are what? They are long chain fatty acids and alcohol. Let's see how. So the alcohol part in majority of the lipid happens to be glycerol. Do you remember glycerol part when we are doing the digestion of lipids in chapter digestion and absorption? Done with this section, children? Did you copy everything? Everybody? Most important alcohol in the simple lipid is what? It is glycerol. Let's draw the structure of the simple lipid. Now we will join the glycerol, that is a particular alcohol with different fatty acids using different kinds of bonds. So this is the glycerol molecule. We did this thing in a reverse order when we were studying digestion and absorption. So this is my glycerol. I will be adding, this is my fatty acid, general formula of fatty acid RCOH, where R can vary. Let's see this thing also. General formula first of all, fatty acid. I missed on this, sorry. Fatty acid, general formula is RCOOH, where R is having a number of carbon from C3 to 19. C3 to C19 is the number of carbon the R may contain. Okay, fine. Moving ahead. This was the introduction about RCOH. Let's move ahead. Now what happens is we will do a condensation reaction like we did yesterday for peptide bonding. Just a minute, I will be scrolling up. This orange section I am going to remove. That is, I am going to remove what? I am going to remove the water molecule, and obviously if water is removed, what is going to happen? You know, CH2O. Yes, I am doing Shillong. Just a minute, wait, let me finish up the reaction. Now this is what is called as the, just I will mark this whole bond, this whole thing is called as the, this is an ester bond. This is what kind of bond? This is ester bond. So in a lipid what we have is, we have formation of ester bonds, and this is called as monoglyceride. Just a minute, we'll scroll it. Yes, Shillong, please copy. Are you able to understand whatever is being taught? Each one of you. So like peptide bond we had in amino acids, similarly we have ester bond in between the fatty acid molecule and the glycerol to form a simple lipid. So glycerol is not a part of fat, but yes, it is the particular skeleton on which you are going to add one by one the fatty acid molecules. Now this is monoglyceride molecule, copied this section. Tell me yes, no. Okay, fine. Okay, Tamilong, Senapati. Let's just finish up with lipids. We will have some questions after this from proteins and lipids both. Copied? Tamilong, Senapati, Itanagar, Shillong. Okay. Nice, I am proceeding. Now what I am going to do is that I am going to add one more fatty acid to this monoglyceride molecule. I will be naming it R2COOH. Let's see what happens. Again there will be removal of a water molecule. This OH and this H. So what we are going to remove? We are going to remove the RCOH. Sorry, we are going to remove the water molecule, and this is going to form again what? Already it had a CH2O, COR1. Now it is going to have another molecule also engaged in the same bond formation, but this time it is a second fatty acid, and the third is still waiting. The third is blank. The glycerol. So this is what is called as diglyceride. So diglyceride molecule has actually two ester bonds, one over here and one over here, CO bond. Clear? Now what I am going to do is that I am going to again add one more fatty acid, R3COH. If you remember, in digestion we were doing the reverse order. We started with the triglyceride and we broke it into glycerol plus 3 fatty acid. But this is how we are making the triglyceride from glycerol and fatty acids. So the whole process is going in a reverse manner. Again we are going to remove a water molecule. We are going to remove this water, this thing. Going to remove this thing. What I am going to get is CH2O, COR, CHO R2 CH2 O COR3. So now it has how many peptide bonds? Now it has, sorry, how many ester bonds? It has 3 ester bonds. So there are 3 ester bonds present in whole of these molecules, and this is what is said to be is triglyceride. So this was the whole formation of monoglyceride from glycerol plus 1 fatty acid. Oh, sorry. Yes, this was the formation of monoglyceride from 1 glycerol and 1 fatty acid. Then we made diglyceride from 2 fatty acids and 1 glycerol, and finally we had 3 particular molecules of fatty acids attached to the glycerol to form the molecule called as triglyceride. So triglyceride is an example of what? It is an example of simple lipid. This is an example of simple lipid. Why? Because we defined a simple lipid as what? We defined a simple lipid as a long chain of fatty acid and alcohols. So the number of long chain of fatty acid is not defined. So monoglyceride is also simple lipid, diglyceride is also simple, and triglyceride is also simple. So all of them, all the 3, they belong to the group of simple lipids. Clear? Everybody sorted? Everybody clear with this idea? All of the things. Nice. Now we will talk about simple lipids categories. Simple lipids are divided into 2 categories. They can be either saturated or they can be unsaturated. So this is unsaturated fatty acids. So we have 2 different kinds of fatty acids. Saturated, we all know that there is only carbon single bond carbon present, and for unsaturated we know that there can be carbon double bond carbon. We know these things, isn't it? This is very basic. Or carbon triple bond carbon present. So if you have double bond, triple bond, it is said to be unsaturated, and only single bond, we call it saturated. Clear? Everybody? Okay? So this saturated is basically non-essential fatty acid. It has non-essential. FA is fatty acid, and it was AA for amino acids. Okay? But this happens to be the essential fatty acids. Okay. This is most importantly, saturated one are formed in our body. All the saturated, they are present in animal body, or we can say they are formed in animal bodies. So they are formed in animals, so they are not of any requirement. So we can say like examples, we all are aware about it. Not good for health, ghee, butter, they are saturated fatty acids, not at all good for health. Okay. So all the animals, they have high amount of saturated fatty acids, and examples of saturated fatty acids are palmitic acid, it's given in NCERT, which has 16 carbon, and the next example is stearic acid, with 18 carbon. These are the examples of saturated fatty acids. Moreover, if you talk about the unsaturated, apart from it being essential fatty acid, these are the ones which are essential for our body. They are found in what kind of substances? They are found in vegetable oils. We all know what vegetable oils we have. We have mustard oil, we have coconut oil. At all these particular places, what we have is, we have these typical kinds of unsaturated fatty acids. So they are basically why they are? Because they are metabolically more active. Why they are required? Why they are thought to be good? Because they are metabolically more active. And do not get stored in your body. So they don't, people consuming these types of things, they are not complaining about obesity, no cholesterol. These are things which are very, very prominent nowadays. Lifestyle disorders, people eat more, exercise less, no cholesterol, no obesity, and obviously we have done with the cardiovascular disorders also in the heart section. So there is no disease regarding the cardiovascular system, there is no heart diseases. So if you become a doctor, you should advise your patients to stay away from ghee and butter. So no cardiovascular diseases. Okay, no BP also, same things. So these are the particular kind of things which are said to be unsaturated. Now, unsaturated examples, let's have a look. So we have examples like essential fatty acids or unsaturated, oleic acid, linolenic acid, or you can say linoleic acid first. Talk about linoleic acid, and then we will talk about linolenic acid. There is an N over there. You can see additional N, linolenic acid. These are 3 acids. Apart from that, this arachidonic acid has been asked many times in NEET exam. Arachidonic, earlier in AIPMT also. So we have arachidonic acid. Okay. So we have oleic, linoleic, linoleic and arachidonic. Okay. So all of them have certain number of double bonds. First of all of them are 18 carbon compounds. Apart from arachidonic, it has 20 carbon. Now this 20 is including the COH group, because remember I told you there that this R group contains how much? This R group contains C3 to C19. See this thing? C3 to C19. So if you talk about the other parts, that is if you talk about this palmitic acid 16 carbon, this is including the COH group. Stearic acid 18 carbon including the COH group. So again oleic acid, this is basically a molecule having 18 carbon. All of these three, all three have 18 carbons. Okay, but the exception is that what? They have number of double bonds is variable. If you talk about number of double bonds, this is double. Okay, number of double bonds, it is variable. Like in example, for example, in oleic it is 1, in linolenic it is 2, linolenic it is 3, and arachidonic has 4. Okay, if you go to market, you will listen to a term, you will hear a term called as MUFA. How many of you have heard MUFA? Yes, tell me. How many of you have heard MUFA? It's too thick. Have you heard about MUFA? If you go go to market, take the packets of oils, different packets of oil, they claim to have MUFA, and this is the ones, these are the ones which are PUFA. Okay, so MUFA and PUFA are what? MUFA is monounsaturated fatty acid. And what is PUFA? Since they have 2 and 3 double bonds, it is polyunsaturated fatty acid. Okay? Clear? Everything is clear, everybody? So this was the simple lipid. We'll take a small break. First let me know, is everything clear? Then I'll talk about break. I made a mistake of asking first about break. First let me know if everything is clear, then I will talk about break. Yes, Tamenlong, Shillong, Itanagar, Senapati. Clear, children? Sorted everything? Clear? Okay, very good. Then you can go for a break. We'll come back and continue with compound, conjugated, do some questions. Okay, fine. Can we resume after break? Yes. Some people are dancing, some are gossiping. Yes, children. Refreshed? Everybody? Okay, nice. So let's continue. We were talking about MUFA and FUFA. Okay. So now if you go to market and you see different types of oil pouches, written over there contains PUFA and MUFA. Now you will be able to very well judge what are they. So MUFA is basically monounsaturated fatty acid. So this kind of fatty acid is important for our essential. They are basically essential fatty acids and they are required by our body. Okay, and then we have PUFA. PUFA is again the linoleic and linic acid which is required for our body, essential fatty acid. So these are different kinds of fatty acids falling into category of unsaturated. Always keep in mind the saturated ones are non-essential and the unsaturated ones are essential. So ghee, butter, they don't contain any kind of essential fatty acid. Yes, they might be containing different kinds of nutrients, different things, but however they do contain anything important that is for our body. Okay, so let's move on with the next category that is basically called as conjugated. If you just go back and see the division I made, so I made three things, that I made simple lipid, compound lipids or conjugated, the same thing. It's compound or conjugated lipids. So we have three different categories of lipids: compound, conjugated, simple, compound and derived lipids. So if you talk about compound or conjugated, we have different kinds of examples, like the one I told you about phospholipids. So phospholipids are what? Phospholipids are again the examples of compound lipids. What happens in compound lipids is that this is basically having, let's see what does this have, two fatty acid, one glycerol, nitrogen, S3PO4. This is a formula for phospholipid. Since phospho is present over here, so they are said to be phospholipid. And the examples of phospholipids are what? The examples of phospholipid I just now told you. What was it? It was lecithin. Okay? You have cephalin as well, and you have sphingolipids. Okay? So where is this sphingolipid present? I taught you myelin sheath, remember? It's present in myelin sheath. Okay? Where is cephalin present? Cephalin is present in egg yolk, and blood platelets. And where is lecithin present? Lecithin is basically present in the cell membranes. Sorted? Clear? Yes. Shillong, Tamenong, Senapati, Itanagar. Am I clear up to this? All of you. So this is what is compound lipid. Very simple. Not to worry much about it. The first one was, just like, let's mark it A. First example from compound lipid, phospholipids. Let's see the second example. Copied this, children? Yes. Okay. Second is glycolipids. So this glycolipid has what? It has one fatty acid and it has sphingolipid, and one galactose. You know what is galactose? Galactose is a monosaccharide. Okay, where are they found? Glycolipids, they occur in ganglia or say neurons. Okay, this is glycolipids, the second compound lipid. Done with the compound section. Start up with derived lipids. So what is derived lipid? The third section. So what are derived lipids? The lipids, simply lipids derived from simple or compound lipids. So if you have lipids derived from simple or compound lipids, we call them to be what? We call them to be derived lipids. So these derived lipids are of different categories. Like first we have steroids, we have sterols, okay, so these steroids and sterols, both of them have a cholesterol ring. Cholesterol ring is called what? The chemical formula is cyclopentano perhydrophenanthrene nucleus. It's important. So they have what? They have cyclopentano perhydrophenanthrene nucleus. Now you know many of the particular hormones are also having cholesterol. They are steroid hormones. Remember glucocorticoids, mineralocorticoids, testosterone, progesterone, all of them are steroid hormones. So they are very much essential that we have to have in our body different kinds of derived lipids to make a very good level of these particular molecules available. So if you need to have a good level of steroid hormones, we need to have cholesterol. In that ways, your fats are very, very important for our body. Okay? Clear? Can we have some questions? Are we clear up to this? Lipid section is over from my side. Do you have any questions from this particular part? Amino acid is done, protein is done, lipid is done. See some questions and then start with nucleic acid. Let me know when you're done with copying. Tamilong, Senapati, Itanagar, Shillong, clear? Clear? Just copied. What about clear or not clear? So if simplest amino acid was glycine, which is the most complex amino acid? Tell me. If simplest amino acid was glycine, name the most complex amino acid. Can we have some questions? Yes. Tell me. Most complex amino acid. Quickly. Did you Google? Don't Google, please. Tamilong, Senapati. Okay, very good then. Tamilong, Senapati, Itanagar. What about your answers? Okay, nice. Very good, Shillong. Keep it up. So, tyrosine is not aromatic. Tyrosine is also aromatic. But yes, tryptophan has an additional heterocyclic ring attached to it. Apart from being aromatic, its benzene group is present, plus it has a heterocyclic ring also attached to it that makes it the most complex amino acid. So if simplest was glycine, the most complex is tryptophan. Okay, next question. Yes. Most complex lipid in the cell membrane. Shillong, Senapati, Itanagar, Tamilong. Just now I have taught you this. Think of your answer, don't be in hurry. Shillong, yes. Senapati, very good. Very good, Shillong. I guess this is from the second section. Yes. So the most abundant, yes, Tamilong, glycolipids are the most abundant lipids in the brain. Don't get confused, please. This is present in brain. Obviously, brain, we mean to say by brain, we mean to see myelin sheath. So this is the most abundant lipid present in the myelin sheath of the brain. But this is the most, if the question comes for the cell membrane, you have to mark it with phospholipid. And in phospholipid also, if you need to take more appropriate option, we would like to have lecithin. So lecithin is the particular type of phospholipid which is most abundantly present in all the eukaryotic cell membranes. Clear? Let's come to the third question. Let's see how much we remember from the last class. Which of the following is alkaline amino acid? Yes, alkaline amino acid among the four options. Quickly. Okay. Got an answer. Yes. Tamenglong, Senapati, Itanagar, your answers please. Shillong, only one of the sections I have answered, the other section yet to answer. Yes. Okay. So if you just flip through the pages, you would be able to find that I gave you 2 examples yesterday of exactly of the particular amino acids found in histone protein, isn't it? And that was arginine and lysine. So you have 2 amino acids which are basic. So this is the basic, one of the examples of basic amino acids is arginine over here. Okay. One more questions or shall I continue with nucleotides? Nucleotides and nucleic acid. One more question or shall I continue? I guess I should continue the topic. Okay, the one with more people did not answer. Why? Why it is like that? There are more people, the answer should be more. Yes. The more people, let's like, what is it? Section A or section B? The more people is section A or section B? More the people, the more they are involved in gossip. I am seeing them. I will just make a note to Ashish. Okay. This is A section with more people. Yes, A section, why did not you answer? B section is complaining about you. Yes, A section Shillong. B section is complaining. You people don't answer. Okay. Just please answer the questions. Okay, you left the group. Okay, no issues. We'll see to it. So B section is complaining about you. A section, you people are not responding. This is not done. Okay. So please answer these questions, because yes, these particular kind of questions, they do come in your NEET exam, and that is going to be, yes, hello. Okay, so these type of questions, they do come in your exam. So please do answer these things. I did not tell you like children. You're not in 8, 9, 10, isn't it? You people are grown enough to understand things, what are important and not important for you. So please answer the questions. I'm writing these things. I'm taking the pain for all of you. For each of the center, I'm taking this pain. Every teacher in fact takes pain to write questions, teach you, obviously to get a result from you. Okay? So that you can get something from here. Okay, so now how do you find biomolecules? How do you find biomolecules? More Senapati wants more question. But Senapati, you are answering. Are you? Yes, you are answering. Okay, then it's okay. Okay, let's have one more question. I mean to say, is it interesting or terrifying, or it's like normal? How do you find biomolecules now? Terrifying? Interesting? Okay, normal, average. Okay, answer this question now. Yes, both the sections with more and less Shillong. Yes, now section B makes sure that they are mentioning section B after that. Good. Yes, section A yet to answer. Senapati, Itanagar, Tamenglong. Child, answer this question please. Yes, Shillong section A, answer this. Okay. I will show you something and let me see how you change your answer. That means you are not mentally present in the class because I have taught you this thing today only. Can you see this thing? Everybody will answer D. Many people have answered D. Can you see this thing? Lipids have a double energy give double energy compared to carbohydrates. Can you see this thing? Would you like to rectify your answer now? Would you? What should we answer? Obviously lipids. Lipids always give more energy on oxidation. Whenever you oxidize lipid, you get to have more amount of energy. Okay, let's have one more question. We will start with a new topic in the next class on Monday. Let's have some questions. Continue with questions today. Okay. And alpha helix represents, let's see, very easy, primary structure. Primary, secondary, tertiary structure. What kind of structure does an alpha helix represents? Yes, alpha helix is present in which of the following structures? First, let's answer the question number 5. Yes, question number 5 is alpha structure is present in which of the following structure? Or primary structure, secondary structure, tertiary structure. Where would you find the alpha helix thing? Obviously, you are going to find the alpha helix if you flip through the pages. Very good, Tamil Long. Good. Nice, Shillong. Very good. This Shillong is which section? 5 equals to B. Which is this section answering? First or second? Okay, nice. Very good. So, we have the alpha helix structure representing in secondary structure, and if you remember, the alpha helix has a specific property that all the alpha helix are right-handed. You need to learn this also. Compulsorily, no left-handed alpha helix is found. All of the alpha helix form present in the biomolecules, obviously in the biological world, they are all right-handed. Just compulsory with this thing. When we talk about bonds formed in the tertiary structure, obviously if you go through the notes, you have all the above bonds which are found in the tertiary structure of protein. So, it requires all the above bonds, peptide, hydrogen disulfide, hydrophobic, ionic, all are required to form the tertiary structure of protein. Okay, very good. Nicely performed, very good. But yes, you need to do what? You need to go back home and you have to have a good idea. I am not leaving your class, don't Don't be in hurry. I'm not leaving. You have to go back home and just try to practice questions from the previous years. That will be helping you a lot now. So if you go back home and solve all the questions from lipids, from the proteins, that would be very, very beneficial for you. Okay? Yes. Section B, what is going on? What is going on in section this B section, Shillong? What is happening? Okay, fine. So what are biomolecules? We're done with this thing, yesterday's class. So we started with protein section today, isn't it? Composed of CHON and might have, not compulsorily, but might have iodine, iron and phosphorus. So we talked a lot about protein. In fact, they are heteropolymers. So if a question comes to you, what are proteins? They are polymers. What kind? Homo or hetero? You have to answer they are heteropolymers. Okay, this is important. Just keep on marking important things. Okay, now amino acids are what? They are substituted methanes, because our group over there, that is having different kinds of molecules, different kinds of combinations. So this was primary structure, secondary structure. Secondary had two types: alpha helix, always right-handed, and beta pleated, that is present between two polypeptides. One more thing, if there are three polypeptides, just you can add over there, if there are three polypeptides, they are making tropocollagen. Helix, and example for tropocollagen helix is collagen. Okay, just make a note of it before leaving the class. I will just keep on marking important points now. If you are leaving the class, you will miss out those things, and that will be obviously a part of the test when we will conduct the biomolecule section. Okay? Okay, fine. Everybody, please be seated. Okay. Now, next thing, just add these things. So, if it is one polypeptide, it is alpha helix, two polypeptides, beta pleated, and three, it is tropocollagen or collagen. Clear? Shall I move ahead? Clear with this? Tertiary structure, talked about bonds, different kinds of bonds. Quaternary hemoglobin. Okay? You can add one more thing over here, hemoglobin plus insulin. Insulin also has quaternary structure. Make sure you are not leaving the class before me. Until unless I bid you goodbye, you are not supposed to leave the class. Okay, so insulin plus hemoglobin are the molecules giving you quaternary structure of protein. Everybody, Shillong, Tamilong, Itanagar, Senapati, clear? Section A, section B both. So we have all the amino acids in our body, L form, in bacteria D form. Lipids, the ratio of hydrogen and oxygen is not in the ratio 2:1. Why? Because oxygen is comparatively very less amount, present in less amount. Present in globules, carbohydrates, more energy than carbohydrates, less space to accommodate. Okay, because they are hydrophobic in nature, obviously. And we talked about lipids, fats and oils, about the melting point. Types of lipids, glycerol, simple thing, glycerol, keep on adding fatty acids, will keep on making it more complex. Monoglycerides, diglycerides, triglycerides. Then we divide it into, okay, there is an exception in unsaturated. What we told is that, we told that this is present in animals, isn't it? Present in animals, formed in animals. But there is an exception of your favorite fish. This fish has unsaturated fatty acids. Just make a note of it. Fishes have, they are animals, but they have unsaturated fatty acids. There is an exception. That is why fish is considered to be the healthiest of all non-vegetarian food. Copy it. Fishes have unsaturated fatty acids. Oscillating to and fro, out and in of the class. Okay. So MUFA and PUFA, we did this all. Compound lipid, derived lipid, easy. Steroids, all the hormones of the steroid hormones, basically the particular one we studied in the chapter 22, chemical coordination, we have done those things. So we know now that there are many different kinds of hormones which are having steroid property also, and they have what? They have a characteristic cholesterol ring. Okay? Okay, fine. Then you answered many questions nicely. Very good for that. Okay, done with the particular sections from lipids and proteins. Okay. Okay, fine. So let me know if you have any doubts, or you will go back home and come to again on Monday with doubts. Yes. Let me know, do we have any doubts? Senapati, Shillong, Tamilong, Itanagar, all of you. Do we have any doubts? No doubts? No doubt is also a problem many a times. Okay. No doubt is also a problem many a times. I should have, like, you have to perform good in test because you don't have any doubts. You have to perform good in test, and Monday we'll come back. We'll start with nucleotides, nucleic acid, let's see, carbohydrates, let's see how much we complete, enzymes, and primary and secondary metabolites. These are the topics left from this chapter. Okay, fine, you can leave the class now, free to go. Thank you so much, everybody. Senapati, Tamilong, Itanagar, Shillong. Just go back home and study hard. Bye-bye. Thank you so much. Tata, take care. Study hard.